Welcome again. I still have a scratchy throat. But I wanted to make one last video here to get you headed in the right direction for our final project, which is an exponential modeling project. We'll start by just running through the document here. Of course, you'll be able to view this when you get to the assignment, but I'm going to run through essentially an example of how to knock this thing out, and this will be the last thing that we do for the semester. So before you begin the project, please take a minute to read this section on fitting exponential models to data. So if you click that link, it'll bring up a little quick section here just describing how we use exponential models to model data. It'll talk about exponential regression, which is what we're going to use. Remember, we have tools to help us with this, so you don't have to actually do all the calculations on your own. But take a minute to read through the examples so you can get the hang of what we're going to do. Once you've done the reading, you're ready to tackle the assignment. So we're going to make a fake set of data based on your UMID. So that'll be the first thing you do is you get basically 10 points for just listing your UMID here. Once you've done that, you're going to use your UMID to create a data table. And what you'll do is either click this link or this link, and you'll be taken to this little web page that I whipped up. It's nothing fancy, but what it will do is take your UMID and create a data table. This data table is of a fictional country. It's the population each decade from 1910 to 2020. And I'm going to use the same fake UMID that I used in the other video. So it was 5, 4, 3, 2, 1, 2, 3, 4. So there's that UMID. And then all you do is press Create Data Table. And you're given a set of data. So you can see the years are listed on the left. And then the populations of this fictional country are listed on the right. Okay? And what you'll do is for number 2, you'll record that table, write it out in your notebook. For problem 3, we're going to just copy and paste that data into Desmos. It's easier than having to type it all out on your own. Okay, so I recommend you just copy and paste it. So I just use my mouse here. I highlight the data. I'm going to copy it and then go over to Desmos in a new window, and I'm going to paste the data. When I do that, Desmos will automatically zoom to fit the data, and it'll make a scatter plot. So this is what you should see. You'll notice I've got these green dots here that indicate those populations. And here's the table that's been displayed here. So you get 10 points for doing that. And then what you're going to do is make a sketch of that scatter plot, including labeling your axes. So go ahead and just use the plot that's given here. You can start your X and Y axis labels at the same years and population numbers that are listed here. Don't panic about these labels on the Y axis. Those are just numbers written in scientific notation, but they represent the Y values that are listed over here in your table. So make a sketch based on this graph so that you can get credit for number 3. In number 4, we're going to use this regression that we talked about in the reading. And Desmos has a built-in tool to do this for us. It's very similar to the regression that we used for the quadratic models. So over in Desmos, we want to do that approximate relationship between y1 and x1. So I type y1, and then I get that tilde button again. Remember, tilde, if you're using the keyboard that's provided, is located in the ABC section right here. Okay. Y1 is approximately equal to, and then we use the form that's listed in the document here. We're going to do this one here, a b to the x. So we're going to type a times b, and the exponent is going to be x1. When you do that, cool stuff happens. First of all, Desmos calculates the values of A and B. So you need to note those values because you're going to write those out in your answer for number 4 there. It also draws in the model. So this black curve here, let's make it blue. And I like my data points red. It draws in that blue model. So this function that is drawn here on the graph is the model that we're using to represent the real data, the real fake data that is listed in the table. And instead of the letter A and the letter B, we're going to use these numbers that are provided here to answer the question. So in problem 4, you're supposed to use those values A and B to write out the equation of your model. So write out all the decimals, and you're going to have y equals decimal number times decimal number raised to the x. The letter y and the letter x stay in your equation, but the A and the B are filled in with those numbers. For number 5, go ahead and sketch that curve that was generated and put it right on the same picture that you used for number 3. So you just draw our blue line in on your graph. Okay, so we've got our model now. I do want to show you that there are 2 ways to represent the model, though. So one way is with this base b. In our case, the base is 1.0129. This is an important form because it actually shows us the growth rate, right? This 1.29% is the growth rate for the population over those 110 years. So that's one way we can use it. And then another model, another form for the same model that you might come across is a model that has base E. If you want to write this in the form of base E, you just have to make a couple adjustments to your regression. So we're still going to write y1 and tilde. We're still going to have A, but instead of multiplying by b to the x, we're going to multiply by e raised to the exponent bx. So we need b and x to show up there in the exponent. So I usually put those in parentheses. It's bx1, sorry. And when you do that, notice this red curve comes up. Let's make that one orange since I already have red dots. And it's the exact same model as the blue one, right? It covered it all up. But it's written with base E instead of base B. And so the values that we'll use for that model are listed here as 0.022187 and 0.128224, okay? And when you answer number 6, you'll just write out that equation. Okay, when you get to number 7, we just want to know what double the population is from 1910. And a fast way to do that, believe it or not, is just to copy my population in 1910. I'm just going to copy that. And I go down here and I just multiply it by 2. So you can see that value here. You're going to record that number for number 7. In number 8, we're going to use our model to find out what year our population equaled that double value. When did the population double from 1910? And actually, to do that here, all we have to do is stick a y equals in front of that calculation we made. So I'm just going to stick a y equals in here, and notice it draws this horizontal line at that y value. And to figure out what year we hit the value, you just click this dot, and it's about 1953. So for my answer to number 8, the year is 1953. That's when our population doubled. In number 9, we want to find the population of our country in this current year, which is 2024. For that, I'm just going to add a vertical line to my graph from the x-axis, x equals 2024, and you'll see it draws that vertical line, and then I can come up here and click and find the population. That's 2023. I typed the wrong number here. Let's fix that. Let's put 2024 in. Let's click the value, and so it's 4.1473 times 10 to the 8th. You can write it out in scientific notation just like that, or you can write it in standard form by moving the decimal if you want. But that's going to be the population of our fictitious country this year. Now, the last thing you're going to do is you're going to make a screenshot of your entire Desmos creation with all of the appropriate values there, and then post it to the discussion board, because everybody's going to have a little bit different data. So before you make the screenshot, make sure you've highlighted those 2 points from the last 2 questions. So one of them was, what year did we hit the double population? of 1910. That was 1953. And the other one was, what's the population in 2024? So I've got those dots on there. I'm going to make a screenshot. I'm going to post it to the forum and say, yeah, baby, the semester's done. Hopefully this video will help you knock this thing out. I want you to get a good score on this. So please, if you have any questions, feel free to ask. I'm happy to help. In the meantime, take care.